The SD Ruby podcast is brought to you by New Relic.
My name's Guyren Howe. I'm a Rails and database consultant. I guess I'm kind of the resident Postgres cheerleader here at the group. There's people nodding. I'm here to talk to you tonight about Postgres rules, which is a fairly Postgres specific but rather powerful feature. And if there are any of you who are wrestling with scaling and speed in your databases, it might be something you could find useful. Of course, what I'm talking here, if you're a Rails acolyte, is sheer heresy, because as we all know, as David Hennemeyer Hansen has told us all, you don't put any intelligence in your database. Not sure that I agree with that. I think you find that judicious application of code in your database can make your application scale an awful lot easier. But anyway, I'm here to talk about rules, and this is what the SQL command in Postgres to create a rule looks like. It looks an awful lot actually like creating a trigger, and they are somewhat similar to triggers. So create a rule on a particular event, insert, update, delete on a table. You can give it a where condition, and then you can give it the do, also or instead, specific SQL commands. What a rule does that is very different from a trigger is a trigger will run as the database engine is doing things in your database. Right, so you can tell it that as a row is getting inserted into a table, you want to also run some code. What a rule does is it happens before that, and it actually modifies the incoming SQL. This is kind of esoteric. Triggers are simple, they're fairly easy to understand if you're at all familiar with SQL, and their behavior is much more predictable than this feature is. So this is something not to use lightly. It's something to use if you're fairly comfortable with SQL and you are really wrestling with trying to scale the performance of your database application, or if you want to do insertable views, which I'll get to in a second. So the question is, why not just do everything with triggers? And as I've suggested already, what you get, the main benefit is that rules can be, depending on what you're doing, a great deal faster than a trigger. The other thing that rules will do is views. In fact, when you create a view in Postgres, you're actually using a rule. This is basically syntactic sugar for this. Can you read that? So a view is just a view is just a rule that runs on a select statement, and this replaces whatever it is, the sort of dummy table it creates with a different query, which is fine. Where rules really come into their own is if you want to put some intelligence in your database and you want it to run fast. The reason is that if you're doing bulk inserts or bulk updates in your database and you've got any triggers in the mix, then if you're inserting 2,000 rows, you're going to be running the trigger 2,000 times, let alone 10,000 or whatever. I've had applications where I'm doing more than that. The rule will still only run once. So if you want some logic in your database that's going to take that insert and also log something about it, the results of using the rule, if you do it right, can be dramatically faster. But they look like triggers, they're not triggers. They can very often do things that seem unpredictable unless you really, really understand what rules are doing. So I'm warning you, if you're going to use rules in your application, read and understand how they work and test them very carefully. I'm really serious about this. You can blow your leg off with this thing. This is what you need to read. There's one particular page in Postgres documentation, how update rules work. Rules on selects are fine, they're not going to cause any damage, but you might as well just use a regular view, as this amounts to the same thing. If you want a rule to run on insert, update, or delete, you need to very carefully read this page, and it's fairly slow and dry reading. I'll give you an example of why you need to understand what it's doing and indeed give you some instructions on how to blow your leg off efficiently. This is what it says about if you write a rule that has a where clause and an instead, right? And what you get is what gets run, and the two sides of the semicolon I think are actually backwards. So what you get run is the original query with the negated rule qualification added. Right, so you said here's a rule on this table on insert where such and such, do instead something else, right? So what it does is takes the where part, sticks it into the where clause of your original query but negates it. And then it takes the query from the rules, that's the do instead part, and the original query's where clause, and puts that into the stuff that's in the rule. Let me give you an example. Let's say I create a table counts with an ID count, and I want to use rules. This is great. I can do upserts. I can make upserts really like, I insert, but if the record's already there, do an update, which is, kind of tedious and painful in SQL a lot of the time. So this is great. We'll use a rule to do an upsert automatically, right? So this looks like it's pretty simple. It should do exactly what we want, right? So on insert to counts, if there exists a record already with the same ID, instead of doing the insert, add 1 to the count, right? Now I do this. I've got an empty table at this point, right? I do this. You're expecting you're going to have 1 line, right? But in fact, you have that. This is what I mean by you can blow your leg off if you don't really understand what this thing's doing. The reason is, if you read what it says at the top, it turns insert into counts into what's in that box. Right? It takes the where clause from the rule, negates it, and sticks it on the end of the insert you tried to do. And that fails because there's nothing in the database. Okay? So you can shoot yourself in the leg very easily. Here's another example that's perhaps, if you're experienced with SQL, more obvious. I want to log all of the activity in this test table. So basically what I want to do is every time there's a change to the test table, create a record on the test log. So I do this. I create a rule on insert to test, do also insert into the test log. That's great. I'd also have a similar on update rule, right? Okay, and then I do this. Now if you did this transfer over the test log table with a trigger, you wouldn't have a problem. But because the rule, all it does is change the incoming SQL into multiple SQL statements, it's going to take that random and repeat it, not the value. Right? So you're going to get 2 different values. So it's a powerful rule, it's a powerful feature. It can make that, it can let you do stuff like this. I could be inserting 10,000 records into that test table. And if I'm not doing something like this random function, it's going to turn that into 2 SQL commands instead of 1 and then 10,000 triggers. So it's very powerful, it's very fast, but you need to understand, you need to read that section. Let me give you an example of how I've been using it. The other thing you can do with rules is you can, in some databases, most databases, if you create a view, you can often insert into it. Kind of depends on how the database feels about it, but very often it's insertable. In Postgres, a creative view is never insertable by default. If you want it to be insertable, you have to write a rule or a set of rules to handle the inserts and updates on the view. So that's what I did in a application I have where I have financial operations tables as credit cards and cash transactions, and I want to create a reconciliations table. And there's a peculiar sort of a relationship between these two. I want to be able to pull up a reconciliation, and a reconciliation covers all of the operations, all the transactions by a particular cashier between a particular start and end timestamp. So I want to pull up the reconciliation to be able to see that start and end timestamp sort of along with the reconciliation. I also want to be able to look at the financial operations, display them and easily tell whether they've been covered by a reconciliation. So there's two sort of ways I could handle that, right? I can have a reconciliation ID on the financial operations table, or I could put the start and end date on the reconciliations data table and work out the other one. But it's much faster to do this way, put the foreign key on financial operations, because I can work out that direction much more easily than I can work out this way. I don't know if that makes sense. Okay, but the question is, how do I maintain this, right? I'm going to create a reconciliations view that shows the start and end date of the financial operations that are covered by the reconciliation. And it's a kind of long, boring, fairly standard sort of view that does that for me. But now I want to be able to make this insertable. I'm leaning more and more towards putting this kind of maintaining normalization logic in the database rather than in my Rails application, because now I can talk to this database from multiple applications. I don't have to duplicate the logic in different places. It's just in one place and I can't get it wrong. So that's my view. Now I create a rule in two parts. There we go. First part says when I insert into reconciliation, the reconciliations view do instead just pick up the data from that insert, put it in the data, the table that the view is rendering. And then the second one goes into my financial operations table and updates all of the records that are covered by the reconciliation that I just put in. So now I can do the create a reconciliation and update. Possibly, sometimes if we've got a busy, this is for a parking application, we can have 10,000. You know, if there's a ball game or something, it could easily be 10,000 records covered by this, and you just do one insert into the reconciliations table, and boom, all the financial operations that are related are covered by it. So it is, I think that's pretty neat. It's good to be able to do that. It's a very powerful tool. I thought to try and show you some benchmarks or something, but honestly, the results you get are going to be very different to any benchmark I could show you, and they basically scale linearly with how many operations the rule is covering, right? So I'd encourage you to stick to triggers if you're not doing stuff that's a whole lot of data in one go, because they're much easier to understand and get right and much harder to blow your leg off with. But if you really want to speed up database operations and covering a lot of records, take a look at the rules. So,
how do you find maintenance on the rules goes in updating the rules? Whereas like, if I put all this logic in an observer, it's relatively straightforward to maintain it. But I'm assuming you're building that rule in like a migration or very early migration. And then how do you just build another migration to modify the rule?
Yeah, I just copy the up clause from the last migration into the down clause previous. And then you can do create or replace view, and I just had SQL in there.
Okay.
If I care to, I can even like put those two in buffers and diff them if I want to see what I did.
Yeah. Could you? And I guess my other concern or question is like, is there any sort of like testing you worked on to get this to so that you can?
Did I mention that these are dangerous? I wouldn't do this without having a fairly good set of tests on what you're expecting it to do. And you just do model tests and have them right straight to the data, real model tests, not start and.
Okay.
Someone else? Yes.
Do you find any value in writing tests that would just straight write SQL to it, or do you just take it out to the model level and just handle it from there?
You could do it that way. I see if you're some kind of testing purist and you feel like you need every little thing tested in perfect isolation, it certainly wouldn't be hard to write tests that just fired SQL at the database. Honestly, I've found you can get a fairly minimal sort of test that's really only exercising the trigger that way. I haven't had the rule. I haven't really had any that way, so I just use model tests that are, focused on did it create or did it update all these financial operations.
So Guyren, as our resident Postgres cheerleader, can you give the audience a quick couple of pointers as to why you choose that over MySQL or something that's I won't say more common, but that more people seem to use.
I've got a whole presentation I did a couple of years ago on this that actually comes up if you fairly high on Google if you look for MySQL Postgres comparison. So they're both open source, and I prefer open source technologies if I can. Postgres is just it is, I believe, as fast as MySQL. It's more robust, and it has strictly larger feature set, a much larger feature set. So if you're trying to tune a database application to really get the most performance out of it, being able to do things like partial indexes and functional indexes and writing stored procedures in real programming languages like Ruby and Perl and whatnot. There's so many features that can really get the most out of a database if you know what you're doing. And I have found it to be more robust. I've done many, many table rebuilds in MySQL, and I don't ever remember doing one in Postgres.
I would just add a couple features that we use that are pretty killer are the full text search in Postgres is dead simple to deal with and awesome, as well as the GIS stuff. So geographic mapping and doing all the trigonometry related around how far away am I from this point. And there's a native point type in Postgres. I'm not sure if it's also supported in MySQL. So you give it a coordinate point, and then it can do the math on how far away you are from that.
Well, there's sort of the standard almost in the geographic information industry is Postgres running PostGIS. It's really the state of the art. If you're doing anything to do with geographical data, use PostGIS. It's astonishing.
Schemas are awesome too.
Migrations run in a transaction. So if you screw up your migration, it's not going to leave your database messed up. I can go on all day. Yes.
You tried Postgres.app?
Postgres.
App?
Oh, someone's turned it into a double clickable.
Yeah, Roku did.
No.
Yeah, it came out like a week or two ago.
Is it 9.1, I presume?
I believe so.
Cool. That sounds handy. I was going to ask actually if anyone would be interested in some further database like content. We're still planning on having a training day, evening.
Potentially.
Well, if that ever happens, I could do some beginner stuff, but I could also, if you care that I should do it, there's a bunch of other, both Postgres specific and general SQL features that I don't think are widely enough used and known.
John, what is the Postgres thing that you use in your app where you can sort of set, you can almost scope all of the database actions?
Schemas.
Is it schemas? Is that what somebody says schemas over there? I don't understand that feature quite well enough, but do you use schemas in?
I haven't had a cause really, but it's basically just a namespace.
Yeah, it seemed to me like when you have an application where people create accounts in your Rails app, and they have their data that belongs to them, and
like multi-tenant, we have a multi-tenant application, and each tenant has a schema instead of each tenant being all lumped into one database or multiple things.
That sounds really handy.
it's John has an app that he uses that, and it makes it so dead simple because you're basically firewalling off that person's data, that group's data, from everybody else's at the database level. You don't have to worry about preventing someone from going to a different / documents / whatever, because it's just their stuff that they can get.
And is it fully Rails supported?
There's a gem called Apartment that handles all the migrations, handles basically switching between which schema and migrating between them.
So they migrate all your...
Yeah, so you have a public schema, which basically is the framework, and then you also have these individual schemas for each of your tenants. An apartment will, basically when you run migrations, will migrate your public one as well as all of your others. You can set
So basically a product table, each tenant has their own...
Has their own product table, but then you can have shared tables, so basically you can have we use it for all of our tenants to live in a public table, so that if we have referrals or whatnot between tenants, we can have access to those and replicate that in every schema. Whereas, and the other big mess that you get with multi-tenant stuff is you often get like a tenant ID on every table, right? Like this belongs to this user, right? And that gets rid of all of that. So you don't have to keep that. And it basically feels just like it's its own database every time. But migrations are super simple with it.
There was one thing that MySQL did, which is, using multiple databases and splitting the queries between them. So you had like a master and slave database situation. That used to be a lot easier to set up in MySQL, but Postgres has caught up, and if you ask me, it's about to leap ahead as of the next release, which should be out later this year. So I really don't know of a good reason to use MySQL unless you're stuck with a library that's written expecting it's going to be using MySQL.
And Heroku, it's the default database on Heroku now.
Yeah. It's like a 25-year-old project or something now. It's so refined and sophisticated. It's much like Oracle too, so if you think you might be needing to switch to Oracle, or you have clients that like Oracle, you can run pretty much the same code on Postgres and Oracle.
It's also not owned by Oracle.
It is not owned by Oracle, yes.
It's really open source.
Actually, that's a very important point. MySQL is released under the GPL, and more importantly, its drivers are released under the GPL. I'm not a lawyer, so you can't treat this as legal advice, but my understanding is if you write an application that uses those drivers and you want to distribute it, you either have to get a license from MySQL, which can cost in the sort of 5 digits, or you have to GPL your application. Whereas Postgres is under a BSD license or something where you could make your own commercial copy of it if you like and sell it. Just no licensing issues of any kind.
And if you're really into testing, there's an article that's pretty findable on the web about the tests that the guys that write Postgres and maintain it, the tests they have that covers, it's a phenomenal quantity of tests that these guys have written to cover every possible corner of the whole application, and how they run this test suite in various tranches, and depending on what kind of development you're doing. It's probably one of the most well-written articles about how to test in depth and breadth that I've ever read. And you describe the feature set being very rich. And I understand now why they have such an incredible testing suite. There are more lines of test code than there are lines that they're testing. And I thought first that was overkill, but when you read how they do it, it makes total sense of why they do it.
Yeah, it is really robust. It really is reliable. I wouldn't pick up a new release straight away, but I fairly happily migrate up to it like on the 0.1, 9.2.1 or whatever, and I don't remember ever having a problem.
Any other questions?
Just to answer your question with more like technical talk about databases, I think so. I think it's like, I think it's a lot like Active Record has kind of spoiled us in the same way that Rails spoils us as Active Record spoils us as SQL. I kind of imagine it that way. So I think it's great to know more SQL.
Well, it sounds like you and possibly a couple of other people here could be doing some presentations along those lines.
True. Thanks, Guyren.